Welcome. Today's lesson is on exponential functions. We'll briefly study the form, look at the graphs of the more simple exponential functions, look at the laws or rules of exponents, and then do some examples. So the first thing is, what is an exponential function at all? Simply put, it's where the variable is in the exponent. So x to the 3, the x is the base, it's not exponential. 3 to the x is exponential. Other examples, 5e to the x, because the x is up here. 120 times 0.31 all to the x is up here. Notice this one's more complicated, but the x's are in the exponent. And what about here? Well, this is a lot more complicated, but notice where the x's are. They're in an exponent. This is an example of an exponential function. These two are much more complicated than these ones, but they're all exponential. So, what do exponential graphs look like? I'm only going to look at the more basic kinds. A times b to the x, that would be like one like this, or other ones. They look like this. They go to 0 on one side, the other side goes up towards infinity. Although I suppose if a is negative, it would be on the opposite, it would go down towards minus infinity. But, notice the dashed line. This one has a positive, it's 1x, or actually, I'm sorry, it's e to the x. The e is bigger than 1, so it grows. It looks like this. But this one has a 0.31. As x gets bigger, the function gets smaller and smaller and smaller. Dashed lines. If you see, if the base is bigger than 1, it grows. If the base is less than 1, it shrinks. Now notice, bases have to be positive. Why? Because we have a problem. What is minus 1.3 to the 1.2? Try it out on your calculator. You're going to run into some interesting problems. It's going to have an error probably. At the very least, you can't really compute this accurately because the minus sign gets in the way and we have all sorts of issues. But if you take a positive, this now works. It makes sense. Try it on a calculator. This one makes sense. Now, talking about it though, you don't necessarily always want to rely on your calculator. Sometimes you want to actually know what you're doing with exponents themselves to simplify. Here are some rules. These are basically all of the rules you'll ever need for exponents. Exponents multiply together. B to the x times b to the y. Well, if the b's multiply, the exponents add. If the b's divide, hopefully you can see the pattern, the exponents will subtract. How do you get exponents to multiply? Well, you raise to a power and raise again. Think about this for a second. If you had 4 and then raise it to the third power, what's that? That's 64. Or really, it's 4 times 4 times 4. If I raise that now to the 5th power, I'm doing that 5 times. 4 times 4 times 4, times 4 times 4 times 4, times 4 times 4 times, etc. There's 15 of them. Why? Because it's 3 times 5. What other rules? Those are the 3 big rules, but if you put a minus here, it's sort of like this rule here, but with that one being 0. We get 1 over b to the x. b to the minus x is 1 over b to the x. What about the next one? This one is a more tricky rule. When you have a fraction as an exponent, the bottom of the fraction is the root number, and the top is an exponent. So for example, this one's really useful. b to the 1/2 is the 2th root of b to the 1, which is to say the square root of b. Square root of a number is that number to the 1/2 power. b to the 1, that's 1 power of b, it's just b. b to the 0 is, there's no powers, it's just 1. And then 2 rules that have to do with multiple bases. A to the x times b to the x is ab to the x. A to the x over b to the x would be ab over x. I'm sorry, a over b to the x. I said that wrong. But these are the only 2 rules that combine powers. I'm sorry, that combine bases. So let's try all of this. Hopefully it'll make sense. And I want to simplify this really messy thing. So how am I going to do that? Well, what rules can I apply? I've got stuff to the minus 2. This rule should come into play. Stuff to the minus 2, I just multiply the minus 2 into here. But I've got multiple things in here. So I've got multiple things in a power. What happens? Each one gets the minus 2 power. So this is going to be 3 to the minus 2 times a squared to the minus 2 times b to the minus 2. Now there's an implicit times in here. So 9 to the fourth times a to the minus 1 to the fourth times b cubed to the fourth. Now that's messy, but now we just have power to the power, which is multiplication. I have 3 to the minus 2 times a to the minus 4 times b to the minus 2 times 9 to the fourth times a to the minus 4 times b to the 12th. I multiply, right? Now I combine. And I can't combine the a's and the b's, but I can combine the a's and the a's. A to the minus 4th times a to the minus 4th, something to the x times its same base to the y, I add them. I'm going to get a to the minus 4 plus minus 4. How about b? I'm going to get b to the minus 2 plus 12. Now these are not the same base, although I could change it. I could go, this 9 could be 3 squared. I don't need to though. What's 3 to the minus 2? 3 to the minus 2 is 1 over 3 squared. What's 1 over 3 squared? It's 1 over 9. Times 9 to the fourth. Well, let's simplify this. 1/9 times 9 to the fourth. Well, this is 9 to the fourth over 9 basically to the 1th. A to the minus 8th. B to the 10th. Now, when I have this, 9 to the 4th over 9 to the 1th, it's going to be 9 to the 4 minus 1, or 9 cubed. So my final answer is going to be 9 cubed, a to the minus 8, b to the 10th. May look ugly, but be honest, this is better than that was. Now let's do one more example. I'll let you figure this one out. Okay, actually maybe you had some trouble because there are so many different bases. But if you noticed, 2, 4, 8, they're all really powers of the same base. So I'm going to try it. I'm going to do the first step for you and then see how it goes. 4, oops, there's no equal sign there. 4 is really 2 squared. 8 is really 2 to the 3. Maybe you can do it now. Let's see how it worked. What do we have? 2 to the x plus 1. 2 to the, what do I do here? I multiply. Minus 2x. What's this? 2 to the 3. Well, 3 is, and then there's this. I can just add them. So that's 3x minus 1 plus 3. Here, I can just add them. 2 to the minus 2x plus x. So x plus 1 minus 2x equals 2 to the 3x plus 2. And let's simplify this one more time. 2 to the 1 minus x equals 2 to the 3x plus 2. Now, I apparently have forgotten the most important rule for exponents. Exponentiation is 1 to 1. So if I have 2 to the something equals 2 to the something, that means the somethings are the same. Let me write that rule down. It's very important. So b to the x equals b to the y means x equals y. So what do we have? 1 minus x equals 3x plus 2. Simplify that. Add the x over here. Subtract the 2. And I get x equals minus 1/4. Hopefully, this makes sense. Think about it. Try some problems. Until next time.